Hi guys, I'm Abdul and we are here on Learners Connect again. So if you are here with us before, please stay and enjoy. And if you are just joining us, I would love you to subscribe and enjoy more of our tutorial videos on biostatistics. Well, we are going to continue from where we stopped in our last class. We were talking about ungrouped data, finding ungrouped data relating to what standard deviation. So today we are going to be looking at the group data and how we can actually calculate the standard deviation of group data. So we have our range of numbers ready, which is known as your what? Class mark. Then we have our x. X is deduced from our class mark, which is the first value plus the second value divided by 2 will give us the value of our what? X. So we are going to get all of the x value, which is the number of observations. Then we are also going to use our frequency table. Of course, when we say frequency, it simply means the number of observable characters, number of frequent or number of occurrence of a particular character or data in a given statistical value. For example, looking at the range of the class mark for the first one, the frequency is 2. So if you check the second one, the frequency is 8. So if you want to deduce, the one with the highest number of occurrence in this instance is known as what? 8. So first, how do we calculate for the what? X cost? Now we add the first and the second, which is 3.3 plus what? 3.5 divided by 2. So I want you to follow me. You do that. So that means we are going to have 3.4 as our first class mark. Then the second one is what? 3.6 plus what? Plus 3.8, which is going to be what? 7.4. On the second one, the third one, we're going to have 3.9 plus 4.1 divided by 2, which is going to be what? 4. Now the third one, we have 4.2 divided by 4.4. So we have 4.2 plus 4.4, yes, divided by 2. We're going to have 4.3, isn't it? So we do the next one, which is what? Our 4.5 plus what? 4.7 divided by what? 2. What are you going to have? We are going to have 4.6. So having gotten our x, you see, we added the first value and the second one and we divided by 2 to give us the x values. So to get the f of the fx simply means the multiplication of what you have in your x multiplied by the what? Frequency. So that means 3.4 times 2 should give us 6.8. Then the second one, which is 7.4 times 8, which is going to give us what? 59.2. Right? And we have 4 times 5, that's 20. And you have 4.3 multiplied by 8, that will give us what? 34.4. Then we have 4.6, right? Times what? 2, isn't it? So we are going to multiply it and we are going to have what? 9.2. So having gotten that, we are going to get our what? Deviation square. How do we get our deviation square? Now to get our deviation square, we need to have our mean first. To calculate our mean, we simply have our mean equals what? So anytime you are calculating mean on a group data, we use the word frequency. So that means we have summation of fx all over what? Summation f. That is, whatever we have as our summation of fx, then we'll divide it by what? F. It will give us the mean of what we are looking for. So let's add the f of x together. Do it with me. We have 6.8 plus 59, right? We have 59.2 plus 20 plus 34.4 plus 9.2. So we are going to have summation of f of x. Summation simply means adding together the first values. We are going to have 129.6 divided by, so summation of f. So we are going to add all the frequencies together. So that means for this value we have 129.6. Then for the f value, adding everything together, we have 2 plus 8, we have 10 plus 5, 15 plus 8, we have 23, right? Then we have plus 2 which is what? 25. Isn't it? So our mean now will be equals to what? 129.6 divided by 25. So you compute it with a calculator. I want you to do it with me. 0.6 divided by what? 25. So we are going to have what? 5.184. That would be the mean. So from this mean now, we can actually get our deviation from the mean. So we'll square whatever we have. So in this case, we have x minus what? The mean, which is 5.184. Now, when we want to minus it now, how are we going to do? We have 3.4 minus the mean, then you square your value. Whatever you have after minusing this, then you square it and give what you write here. So that means for the first value of x, we have what? 3.4 minus the mean. What's our mean? 5.184, right? Then whatever you have, you square it, and you have what? 3.183. Okay? So for the second value, we are going to have what? X, which is 7.4 minus the mean that you have here. So 7.4 minus 5.184, we are going to have 2.216. Then when you square it, we are going to have what? 4.91. So you have 4.91. We move to the third one, which is 4 minus 5.184. You have 4 minus 5.184. Then you square it. You are going to have what? 1.4. 1.40. So let's move to the next one, which is what? 4.3, right? We have 4.3 minus 5.184. We are going to have what? Whatever you have, you square it. You have 0.78. Then the next one, which is 4.6 minus 5.184. So you have 4.6 minus 5.184. You square it. You have 0.34. You have 0.34. Okay? So after having this value, the square of your deviation, we are going to add them together. Because we are going to see today how we calculate our standard deviation for what? Group data. I told you we'll be talking about the group data today. So that means if we want to calculate the standard deviation for group data now, we are going to have summation of what? F on the bracket of x minus x bar all squared all over summation what? F minus 1. Minus 1 simply means we are actually taking a sample from a larger population, and we cannot, it's not all the population you are taking the statistics of. You are just taking a portion from the population. So therefore, you need to minus 1 from it when you are calculating the grouped data. So now, let's see, adding this together now, what are we going to have? We're going to have 3.184 plus 4.91 plus 1.40 plus 0.78 plus 0.34. We're going to have 10.614. So now, let's see. Multiplication of the frequency and this deviation is going to give you the values that you are going to record here. So that means in this case, you are going to multiply this f times this what? Deviation here. F times this will give you the values that you'll be having here. Okay? So now let's see. 2 times 3.183. We're going to have 6.366 Then you have the second one, which is your 8 times what? 4.91. 8 times 4.91, which is 39.28. And the third value, which is your 5 times 1.40. What are you going to have? 5 times 1.40, you're going to have 7. Then you have your 8 times what? 0.78. 8 times 0.78, you're going to have 6.24. Then you are going to have 2 times 0.34. 2 times 0.34, you are going to have 0.168. And we are going to add everything together. So adding everything together now, what are we going to have? Plus 6.24 plus 7 plus 0.68 plus 6.24 plus 7 plus 39.28 plus 6.366. So we are going to have 59.566. So we are going to have 59.566 as our total values. So we call it the summation. So that means it is the summation that gives us this. Then looking at the summation of F2, what do we have? Summation of F, we have what? 25. So let's apply our data inside our formula. So our S, since the standard deviation is equals to this, so what are we going to do now? Summation of this is gotten already as what? 59.66, 59.566 over summation of F is what? 25 minus what? 1. Are you with me? So now what are we going to do? We divide this and find the square root of what we are going to have. So that means we are going to say that 59.566 divided by, so actually here now we are going to have what? 59.566 all over 24. Am I right? So now we'll look at it and we divide it and we find the square root of your answer. So the square root of answer gives you 1.575, or you can approximate it to 1.58. So this is our standard deviation. I hope you all understand this. Now, if you want to get our variance from this standard deviation, it's just the square of it. Just like how we explained it in our last class, even on group data, getting the variance is just the square of the standard deviation. So your variance in this case now will now be the square of the standard deviation. So that means our V is equals to S squared, right? So we are going to have 1.58 all squared. So 1.58 all square will be our standard, our variance. So we have 1.58 square, which is what? 2.49. Thank you. 2.496. So approximately, or you can leave it, 2.50. So this is how we actually calculate for our standard deviation and our variance on a grouped data. I want you to find time and some more questions relating to this as your work, so that if you have any questions or comments, you just throw it on our comment box section. So now we'll be looking at standard error. How do we get standard error from a statistical um, value or inductive inference? So now let's see. So we'll quickly look at standard error. So if you want to get standard error, the standard error, the values we've gotten before, the standard error is equals to your standard deviation over root of what? N. Okay? Your N simply means number of observation. For instance, a question was given to you and you have, let's say, an example. It said you should find the standard error of the following data. You have 2, 6, 8, 9, and 10. How do we find the standard error of this? It is very, very obvious that this is what? An ungrouped data, isn't it? It's very obvious that you have an ungrouped data. So how do we find a standard error of an ungrouped data? So finding the standard error of an ungrouped data like this, we first of all need to get our standard deviation. Then we divide it by the number of observations. So you can simply solve it in a very simple way when you have your x, which is given, the data is already, and you have your x minus x bar, all what? Square. Isn't it? So now your x values, which is the number of observations you have 2, you have 6, you have 8, you have 9, and you have 10. Okay? So now, looking at this, what is the mean of this particular data? So remember, finding our standard deviation for this, we can simply use root of x minus x bar all square all over n, isn't it? So using this now, we can simply have our what? X minus x bar, that is, we first of all need to have our what? Mean. So how do we calculate our mean? To get our mean, as usual, we have to what? Add everything together and divide it by the number of observation. So looking at this, we have 2 plus 6 plus 8 plus 9 plus 10. So we are going to have 35 divided by 1, 2, 3, 4, 5. So 35 divided by 5 mean is equals to 7. So since we have our mean now, we can now reduce our deviation square. Now, your first one, which is 2, 2 minus 7, that's minus 5. Minus 5 square is what? You have 25. 6 minus 7, you have 1. 1 square is 1. 8 minus 7, you have 1. 1 square is 1. 9 minus 7, you have 2. 2 square is what? 4. Then 10 minus 7, you have 3. And 3 square is what? 9. So you add everything together, which is the summation that you see here. Adding everything together, what are we going to have? You have a 25 plus 1 plus 1 plus 4 plus what? 9. So which will give you what? 40. Isn't it? So to get our standard deviation first, before we get our standard error, we are going to have, mind you, this is for group data, we are going to have our 40 divided by, number of observation given is 5, isn't it? Divided by 5. So your s is equals to root of what? 8, which is, you have 8 here. S equals root of 8. What are we going to have? The root of 8 should give you what? 2 root what? 2, which is what? Which is 2.83. So this is your standard deviation. Now we can actually reduce our standard error now. So standard error now will now be equals to, remember our standard error equals standard deviation by root of n. So 2.8 divided by, what's our root of n? That's root of what? 5. Number of observations, right? So we are going to have 2.8 divided by the root of what? 5. So this is going to be what? 1.25. This shows you clearly, mind you, your standard error should be smaller than your standard deviation. It is always like that. So if it's not smaller than the standard deviation, then you should know that there is an error in your statistical values. So you should note it. The standard error should be smaller than your standard deviation. So what if you are given a group data? I want you to go and try that. Feel free to pass your answer on the video, or you share in the comment box. So what if you are given a group data to work on? How are you going to find the standard error? Now the standard error for group data is given as your S over root of F. So I want you to get questions and solve on this. You can pass the video if you get it right. Alright. So having understand that, we move on to what we know as coefficient of variation. So talking about coefficient of variation, now coefficient of variation is expressed as a mean. That is, when we want to get our coefficient of variation in the statistical data, now coefficient of variation, CV, is equals to your standard deviation all over mean times 100 over 1. Please take note of this. Whenever you are given a question to calculate the coefficient of variation, because it's expressed as a mean, okay? So you have to divide your mean in times 100 over 1. That is, it's going to be calculated on percentage. So let's say our standard deviation for the first question we solved was 2.8. So calculating the coefficient of variation in this particular statistical data now, our standard deviation was 2.83. So which is 2.83 divided by, what's your mean? Your mean was what? 7. Remember when we get our mean the other time? Multiplied by 100 over 1. So it is expressed in percentage. Now 2.83. You have 2.83 divided by 7 times what? 100. See, it will give you your coefficient of variation. 43%. So that's how we get our coefficient of variation. So we'll be moving to look at what we call confidence interval. Confidence interval. What do you understand by confidence interval? And why is it needed in biostatistics? Or let me say statistics in general. So we'll be looking at confidence interval and the need for us to understand what's confidence interval. Now, when we say confidence interval is the level of accuracy or the level of confidence that a particular statistical experiment will be accepted. When you are doing any experiment in scientific world, either being on human or plant or animal, there is a particular percentage of confidence that you are going to have or you are supposed to have before a particular deduction or experiment can be accepted worldwide. Now, let's look at the aspect of biological sciences or in the fact of life sciences in general. In life sciences, the level of confidence, or let me say the confidence interval that will be accepted is 95%. That is, for every experiment that is being conducted, before deducing a theory or law that will be used for it, it should be able to have this 95% confidence. That is, we are able to accommodate only 5% error from any statistical data. Be it you working on plant or what? Animal. But when you are working on human, the confidence interval we are going to have should be 99%. So working on human, let's say you are producing drugs or you are producing vaccines that's supposed to be used by worldwide, it should have a confidence interval of 99%. That is the acceptable error that you are supposed to make in this type of instance, especially on human, is supposed to be 1% error. So this confidence, the confidence interval here is 5%, 5% and 5% error, while this is for plant or animal. But when we are talking about human, the confidence interval should be 99% and the error should be what? 1% error. Now, irrespective of any field or anything you are working on, the highest level of error that is expected or supposed to be allowed is 10% error. That is, you are supposed to have at least 90% confidence, whichever statistical experiment you are carrying out. You are supposed to have 90% confidence, or 90%, at least 90% level of confidence. Before it is going to be accepted. So this 10% is the highest error that can be accommodated. So this is the highest error that can be accommodated in the field. So even if you can't have 0% error, because we are human and there is no possibility that there won't be a mistake. And also, it is not acceptable to have more than 10% error, because it will be believed that that particular experiment will do more harm than the good that is expected. So we'll be looking at how we actually get to calculate our confidence interval, especially in the aspect of life sciences or biological sciences, because we're going to be talking about the humans. Now, or if you check your Z timetable, you check your Z timetable, your Z table. Now, under Z table, you check that the level of confidence for 95% has a deduction of 1.96. So this is the Z number or the Z value for level of confidence of 95%, having an error of what? 0 or 5%. Expressed in decimal, we have 0.05, right? And this one is going to be 0.95. So if you check the Z table for 95% level of confidence, you are going to have 1.96. This is strictly used for life sciences, as they don't deal with human being. So let's check. For confidence interval, if we want to calculate, you have your mean plus your Z value multiplied by standard error. So we are going to have to get our confidence interval value. We have our mean plus our Z, which is our Z time, Z score, multiplied by our standard error, right? So now we'll be seeing an example to this. Let's say we have an ungrouped data. We have to calculate the confidence interval or the confidence range for this ungrouped data. For example, the confidence interval, which is CI, for the ungrouped data. So how do we calculate this? Now, they gave us some parameters that we'll be looking at. Let's say, given that the mean is 3.59, then your standard error is given as 0.1385, and your standard deviation is also given as what? 0.1. 438. So now, given these data, we'll be able to calculate our confidence interval. So when we are checking our confidence interval, the essence of it is to check the range at which it lies between the mean. That is the essence of checking our confidence interval. So let's look at this now and calculate our confidence interval. Now we have our CI to be equal to, what's our mean? 3.59, right? Plus, now for life science, the confidence interval Z is what? 1.96. I told you we make use of what? 95% confidence value. For life science, like the plants and the animal. But for humans, we use 99%. So now looking at this now, we are going to make use of that of the life science, which is 1.96. If you check it, apply by your standard error, which is 0.1385, right? So confidence interval will be equals to 3.59 plus multiply the two first. Applying these two, we are going to have 1.96 times 0.1385 plus 3.59. So let's cancel again. 1.96 times 0.1385, that's 0.271. So adding them now, plus 3.59, we're going to have 3.86. So this should be our confidence interval. Now, this is our confidence interval value for the upper limit value, because since we are looking for the range of this particular confidence interval, we need to get the range from the positive side and we need to get the range from the negative side. So getting the range from the negative side now, so why do we need to get the range from the negative side? Remember, this is it. Let's say this is the value, and you have your interval here. These are the positive side, and this is what? Negative side. So you have your interval, confidence interval here of 95%. So let's say the error in this Z value, the Z score of your statistical data is 5%. And this here is going to have 2.5%, and here is also going to be 2.5%. So that when you add both of them together, you are going to have an error of 5%. And you have a confidence interval range of what? 95%. So since our confidence interval is 95%, that's why we are going to make use of Z as 95%. And we are going to check the range of our value in positive aspect, and we are also going to check the range of our value on the negative aspect. So the first one we've done is on the positive. So we want to look at the confidence interval and this range now. So looking at it from this range now, we are going to have our C of I equals our mean minus our Z value multiplied by the standard error, isn't it? So this Z value is for 95% confidence. So we are going to have, what's our mean? Our mean is what? 3.59 minus 1.96 multiplied by standard error 0.1385. So you are going to have C of I equals 3.59 minus 1.96 times this. You have 1.96 times 0.1385, we have 0.27, 0.27. So you have 3.59 minus 3.59 minus 0.27. We are going to have what our confidence interval here of 3.32. So now let's now check the range of how it is going to be compared to our initial limit. So we have our standard mean here. That means this will stand for the what? Lower limits from this side. Remember we have the negative side here and we have the positive. So looking at the negative aspect is going to represent the lower limit. And now since this aspect is higher than the mean, it is going to represent the what? Upper limit. This is the first confidence interval we find on the positive aspect is going to represent the what? Upper limit. So this one is going to represent the what? Upper limit, right? Good. So checking the range now, we can clearly see that the lower limit is less than the what? The standard mean, and the standard mean is less than the upper limit. So let's look at it as C. That is our lower limit is 3.32, less than our mean, which is 3.59, and our mean is less than what? 3.86. So that is how it goes. Hope you all understand. Good. So this is how we calculate for our confidence or what interval. Now, in our next class, I will be moving to frequency distribution, and we'll also be talking about the measure of central tendencies, which includes the mean, the median, and the mode. Please subscribe for videos and subscribe to our YouTube channel if you still want to get more of our quality videos. If you have any question, feel free to throw it in the comment section, and we'd love to see you next time. Subscribe. Thank you. I mean Abdul Mohammed. Please subscribe to Learners Connect.